6 strict functions. Oh, I made you copies of these. So you have your own. There's 2 pages. Put that away. I mean this. I'm supposed to remind you to wear your shirt tomorrow. So, wear your shirt tomorrow.
Cool.
In case you're thinking about coming to school shirtless, don't.
Darn.
Yeah. So, anyway. Alright, so the first one on here is cosine of theta. We graphed cosine of theta like 1,000 times. So, graph cosine of theta. We don't remember what the cosine graph looks like. We only spent, like 4 days graphing the Ferris wheel. That was a cosine function. You should have in your notes somewhere graph of cosine. Where does cosine start? Cosine starts at where? 1. Okay. And then where is it at pi over 2? Where is it at pi? And then at 3 pi over 2? And then at 2 pi, it's at 1. Cosine is like the serial of trig function. Alright, basic shape. If this is supposed to say basic shape, see they all say basic shape, and cosine's like basic. It's so basic. But the basic shape is a seriable. Alright. See your shape in there. Domain. What can I put in for x on cosine functions? Anything. You can put anything you want. Yeah. So all real. Yeah. What's the range? From -1 to 1. Right.
Can we run it like -1 and less than 5?
-1 less than. How about that? Because 1 is included. Yeah. Alright. Now let's talk about secant, because that's kind of weird. Secant's weird. I don't know if you knew that. It looks odd. Different. I'm not going to say odd. Because then you're like, oh, as opposed to even? No. Weird. Okay? Odd is a weird. So let's talk about secant. First of all, what is secant? It's the opposite. Like I just changed the sign from positive to negative. So it's the inverse. The reciprocal. Okay. So if sine is the sine of theta is what over what? No, like SOHCAHTOA. Opposite over hypotenuse. Then secant of theta. Wait a minute. Secant is not. Secant goes with cosine. Secant is the reciprocal of cosine, is it not? Secant is the reciprocal of cosine. No. Cosecant is sine. Alright, this is adjacent. Oh gosh. It's gonna happen. Adjacent over hypotenuse. So secant would be hypotenuse over adjacent. Okay? Secant is 1 over cosine. That's what it is, okay? Yeah. 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 So we have all that information. We're going to go back and look at the graph, which I can't get both graphs on the screen at the same time in a way that I can actually graph it. So you're going to have to look at your graph and give me the information. Where is it? So. Ooh, there's more information here. What else does this one ask about? Asymptotes. Yeah, why do you think there's going to be asymptotes on a secant?
Because it can be the bottom thing for 0.
Right, what's going to happen when cosine equals 0 and I try and flip that? What's going to happen? It's going to be undefined, right? Yeah. So when we start talking about these reciprocal functions and their graphs, we start having asymptotes because you can't flip 0.
Before I end it.
Alright, so we're not going to fill in basic shape or anything yet. So at 0, what is secant going to be?
1, because 1
1 over 1 is 1, right? Okay, so it's going to be 1. What about at pi over 2? It's going to be 0? I don't know. You have to tell me. I don't know. Why is it undefined? Okay, cosine. Think about that again. Think about what we just said. Actually, what Amber just said. What is cosine at pi over 2? It's 0, right? Does everyone see that cosine is 0 at pi over 2? You probably got like 2 or 3 graphs of that now. You should have your unit circle out. So all that would tell you that it's 0 there, right? Well, can you flip 0? No, you cannot. So it's undefined. At pi over 2, we have one of these right here. Yes, we have an asymptote. It can't get there, okay? Can't do it. Can't touch this. I know you want to dance, don't you? Oh my.
Alpha. So there's one negative pi over 2 as well.
Why? Please tell me.
Wait, because it's negative 1 and
Since we've never seen this one, we're going to graph more of it than we did on the cosine. Cosine is going to kind of and more on this one. Why is there one right here? I guess I could use one. On the unit circle, negative pi over 2 means that you're going pi over 2 spaces in a negative direction. So pi over 2 is the same thing as 3 pi over 2. That's what the negative is, just telling you which way to go on your unit circle. So positive pi over 2 is right here. Negative pi over 2 is right here. You see that? You see why that happens? Look at your unit circle. How many degrees is pi over 2? 90. So if I go positive 90 degrees, I'm going to end up at the top. If I go negative 90 degrees, where do I end up? At the bottom, okay? Which is the same as what going in a positive direction. 3 pi over 2, or how many degrees? 270, right? Okay, so at 270, because we're talking about this one right here, at 270, what is cosine? So, what is cosine? Cosine is 0, which means that here, secant is going to be undefined. Three pi 2. Why is 3 pi over 2? Because it's 0. How often is this thing happening? Every 180 degrees we're getting undefined. We're getting an asymptote. Alright, so now let's try and figure out what's happening between there, okay? Because if we just stick with negative or 0 and pi and 2 pi, we're not going to get a really good shape, okay? So I'm going to pause this and I'm going to let you kind of work on this with the other measurements on here. And all you have to do is you just have to flip the cosine and fill this in and see if you can get a general shape of what a secant looks like, okay? And I'm gonna tell you, they're kind of weird looking. We haven't grabbed anything like this before. It's gonna be, you might want to start off in pencil in case you mess up real bad, you can erase it. But it does look weird. So if you do get something you're like, this can't be right, it might be right. It might be right. So just see what your graph looks like. I'm going to pause it. I want you to start trying to fill it in some, and then we'll come back together. Alright, so what do we got going on here in the middle? What does it look like? Because we've already got 1 point. What does it look like here? A parabola in the middle? Like right here? Okay. Let me do this real quick. So this is basically a cosine function. Okay, that's the red is the cosine, okay? The red is the cosine. So we're flipping all of this, okay? So like right in here, where it's about 1/2, what's that actually going to be when I flip it? It's going to be 2, right? Wouldn't that be 2? So right here, where it's about 1/2, what's that going to be? No, what's 1/2 flip? 2. Is it ever going to come down here? Can I get over here at all? Are any of these right here negative? So if I flip them, will they ever be negative? No. So this is going to look, I totally missed those points. Let's pretend I didn't. Okay? So it's going to look something like that. Alright, red is the cosine function. Okay, and I put that on there just so we can kind of visualize. So remember again, red is cosine. So right here at pi, cosine is -1. What happens when I flip it? Still -1, right? What happens when I flip any and all of these? Are they ever going to be positive? Can I flip a number and it change the sign? No, so all of these are going to go this way, right? They're going to get infinitely closer to that 0, but they're never, ever, ever, ever going to actually touch 0. They just get closer and closer and closer. What happens over here? What's this one going to look like? Yeah, it's going to be the same thing for the same rules, right? And here I'm going to have, like if I kept going, I'm just going to have maybe a 1/2 of 1 because I've got it on the graph. Forever and ever and ever. Yeah. So basic shape, weird. That's your basic shape. Odd as that is. Yeah.
Well, there's
What about the domain for cosecant? I mean, for not cosecant, for secant. No. It's almost all real numbers. Okay. How often do those happen? Every. Okay. Where does it? Where's the first positive? So x can't be pi over 2. But I really don't want to say pi over 2 and then 2 pi or 3 pi over 2 and then this pi over. I don't want to say that. So I need like a rule. It does happen at pi over 2. Now what's the difference between pi and 3 pi over 2. Or, not pi, but pi over 2 and 3 pi over 2. How far apart are they? 180 degrees, which is how much in radians? Plus pi n. That's how often those are going to happen. They're going to start at pi over 2, and then they're going to happen every pi units. So I'm just going to put pi times n. Well, what about these over here? Oh, we've still got them covered, because these, like if that was a -1, that's this one. If it's a -2, it's that one. If it's a -3, it's this one, and so on. So that's how often they happen. Okay? Now, what about the range? All but what? Well,
All except 1 through
yeah, it's never going to be there between that -1 and 1, right? It's -infinity up to -1, and it does include -1. It touches -1. But then it jumps over to +1 and goes off to positive infinity. And I think that we've kind of answered this question in our domain. That's the equation of the asymptotes right there. That pi over 2 plus, or, well, the equation of asymptotes is actually this. That's the equation of the asymptotes. Because we're saying that it can't be, and they want to know what the asymptotes are. That's what it actually is. But it's the same thing. Two specific asymptotes, well, there's one at pi over 2, and there's one at negative pi over 2. Alright, see how that works? Yeah? Pretty easy. Oh, it's weird looking, isn't it? It's beautiful though. Look at that with all those dots and the swirls and the colors. I love it. I do love it. I love it. My favorite. Alright, can I erase that one and move to tangent? Yes? No? Alright. We haven't done tangent yet. It's a little bit different too. Alright, on the unit circle, let me go with this. Tangent's what over what? Opposite over adjacent, right? Opposite over adjacent. Everyone do that? Yeah, opposite over adjacent. Now, on the unit circle, sine is whatever your opposite is. Cosine is whatever your adjacent is. So tangent, using the unit circle, tangent is sine over cosine. That's tangent. Tangent equals sine over cosine. Why on the unit circle is sine just the opposite and not opposite over hypotenuse? What's the hypotenuse of the unit circle? 1. Okay. So whatever the opposite is, that's what sine is. So we're going to use sine over cosine to graph tangent. Let me show you what we're talking about here. So go to, let's just start at 0. This one's another awesome one. At 0, what's sine? What? Sine is 0? Okay. And cosine is 1? Okay. So that's what we're going to graph. I have to back up because all the lines start looking the same when them like they're right on top of them, and I can't tell which one's sticks in the middle. Okay, let's go to pi over 2. What happens at pi over 2 when I try to find tangent? Why is it undefined? What? It's 1 over 0. Tangent at 90 degrees is undefined because you're looking at 1 over 0. When you put sine over cosine, you get 1 over 0. So look what happens. Tangent at pi over 2. Me too. Please pause and one for a minute. Done some cleaning. Okay, so now let's move on. What's going to happen at 180? Well, also known as pi. Right here. No. It's going to be 0. And then somebody gave me this one already. Spoiler alert. What is it? Undefined. Yeah. It's going to be the same with the negatives. Okay, now, again, these are not just straight lines. There's got to be something going on between here. In fact, if I use my points, there are a few points on here that are really easy to use. I can get a better shape on this graph. Remember, it's going to be what over what? Sine over cosine. On your unit circle, which coordinate is your sine? X or Y? Y. Which coordinate is your cosine? X. Okay. So see if you can fill in this graph some more on your own. And again, I encourage you to do it in pencil to begin with, just in case something goes wrong. Alright, what happens about halfway through, right here, pi over 4? It's 1. Why is pi over 4 the way to go? Square root 2 over 2 on both of them. Yeah. What happens over here at negative pi over 4? Same thing, but it's negative, right? So this is the general shape.
So why is it negative?
Because when you get to the fourth quadrant, cosine's positive and sine is negative. If you're doing negative pi over 4, then you're going 45 degrees this way.
Okay.
Yeah. Right. So this is your basic shape for all of them. It just repeats this over and over again.
Maybe like this on the same point.
Yep, it's like it just got shifted. Because these are the same, these just repeat themselves over and over and over again. Just with different signs. So it's just going to be the same thing, just moved over every time. Right. Alright, so what can you fill in over here? Basic shape, that's pretty easy, right? What about domain?
All X except for like the other one. X is not.
Exactly. Yep. Okay, what about the range? Yep. All reals on this. Equation of the asymptote, just move that down here, but without the not equals, put an actual equals. Two specific asymptotes, just flip your favorite two. Go ahead. Just choose a couple. X equals are up and down. Yeah. Okay. So sine is next. You should be able to graph that sine function, no problem. So start graphing that sine function. What's the domain for the sine function? Domain? X. Yeah. Alright, what's the range? Alright, -1 to 1. Okay. Oh, it's so close to 1. I just did sine and I moved my sine down to go on the cosecant because sine and cosecant are reciprocal functions. So let's compare what this is going to look like once we put a secant in. So what's going to happen at all these little spots right here? It's going to be, yep, you're going to get an asymptote. All of these. This is the cosecant.
So instead of -3 pi,
Every pi, yep, exactly. Basically pi in.
yeah, so that would be
Yep. So what's the range, or the domain going to be? It can't be pi in. Yeah. Okay, so what's going to happen in this section right here? Right on the very end, that very last section right there. Down what? This is going to be 1. Because if I flip 1, it's still 1. What happens to the rest? What if I flip 1/2? What does it become? 2. So it's going to open up. What's going to happen down here? If I flip 1, that's still 1. What happens to the rest of the graph? Is there any way for them to be any other shape? They're not going to go up. This one doesn't go up. It's a tear to my eye. It's so beautiful. Now this range is going to be exactly like whose range? Secant. Yeah, this range is going to be just like the range for secant. 2 specific asymptotes, just pick 2. I wish they had, this page had tangent and cotangent side by side, so we could look and compare. But if tangent is sine over cosine, cotangent is going to be what? cosine over sine. Cotangent is cosine over sine. So if I'm looking at cosine over sine, where am I going to have asymptotes this time? What has to equal 0 for me to have an asymptote? If it's cosine over sine. On cotangent is cosine over sine. Which one equals 0 in order for me to have an asymptote? No, if I have an asymptote, sine is 0, okay? Sine is 0 at 0. Sine is 0 at, where else? Sine is 0 at pi. Mm-hmm. Yep.
So number coefficient of pi is going to be.
Yep.
So I'm pretty sure will it be like how the other ones look, they're like this, and like that?
Exactly. It's going to be just the opposite because I'm flipping that number over. So it's going to go the other direction. Yes, that's exactly right. It's going to be
Odd functions.
it's going to be like
These are like 0 too, right?
this. And where that last one had an asymptote at that pi over 2, this one's going to have a 0. That was a horrible one. I just scrapped that one really bad. That one's ugly. Alright. Okay, so I want you to try, where's your next page? I want you to try some of these. Actually, I want you to try all of them in pencil. These are 8 trig functions that start moving them around. Okay? They're going to keep the same basic shape. They're just going to move around a little bit. Alright, so I want you to try all of these. Yes.